This is my progress report for my project dealing with the optimization of lift on an airfoil. I'll start with a high-level summary of my status, then I'll go into more details on the subsequent slides. First, partway through implementing my code in MATLAB, I switched vortex panel methods, going from a very basic implementation to a combined source vortex method. Since the switch, I've created a MATLAB function which can solve for the lift coefficient of a body made up of panels. This is the objective function I minimize. At this point, I've run GA several times with this function and have been evaluating the results. I've also determined the results are highly dependent on the boundary constraints I'm using. My switch to a slightly more advanced implementation of the vortex panel method was driven by initial runs of the basic implementation through the GA function. In the basic implementation, an equation must be dropped and replaced with the kutta condition, which ensure flow leaves the airfoil smoothly at the trailing edge. This choice of dropped equation is arbitrary and leads to inconsistencies in the results. Additionally, the basic implementation would sometimes provide coefficients of lift many orders of magnitude higher than realistic when optimized using GA. The combined source vortex method eliminates this decision, and I found it to be more consistent. I've created a MATLAB function called VPM, which has an input of a vector of y coordinates and an output of the lift coefficient. Since it was created for this project specifically, the function contains set x coordinates, but x could be added as a second input to generalize the function. I've checked the function against various shapes, both symmetric and non-symmetric, and obtained reasonable results. Portions of the function in GA script are shown here. My first few runs with GA yielded spiky results. A more refined example is shown below after I changed the boundary constraints of the problem at various chord locations and reduced the number of spikes. While not ideal, this does still give a general idea of airfoil shape, with a bump at the bottom near the leading edge. Once I've done more to smooth the shape, I'll then implement an SA script using the same function.